This is Dr. Meddie. Big up to all my students, my pals, my friends, OBs, OGs. Yeah, I'm here purposely to analyze more about a practical session. This is chemistry practical. Number 2. The number is all about qualitative analysis. So today, let us talk about one compound consisting of 2 cations and 1 anion, and that common anion is sulfate. So the compound is like this: iron 3 sulfate and aluminium sulfate. So we are going to look at 8 steps taken when we are doing this practical in laboratory. Remember, to do a practical you have to do with some kind of theoretical knowledge. So just convert that thing from theory part to practical part. Thank you. So the first part is heating. Heating is all about decomposing a substance. But before, you have to note the color. The color of the substance, M, is yellow in color. Then crystalline, but not powdery, because all sulfates are crystalline. So if you heat this substance, since it's crystalline, one thing which is going to be given off first is calcium condensate. That calcium condensate will be able to change or to turn white anhydrous copper to sulfate to blue. So in the other side of deduction, we will say substance M is hydrated. Then after you proceed with heating, you will see a careless gas. Since sulfur dioxide comes from the sulfate, and that sulfate is a mother of sulfur dioxide. So that gas is careless. You say careless gas, and observation: careless gas that turns blue moist litmus paper to red, since it is acidic. Then the other side of reduction, you list all acidic gases which are colorless. For example, sulfur dioxide, carbon dioxide. Then after stating those gases down, you also include the anions where those gases are coming from. For example, sulfur dioxide is coming from the sulfate. Then carbon dioxide is coming from carbonate ion. Yeah. Then the last thing under heating is that after decomposing aluminium sulfate and iron 3 sulfate, you'll be able to see a brown solid when hot and when cold. Then the other side of deduction, you include, or you will write that iron 3 oxide is formed. Then after, you conclude by saying iron 3 probably present. Yeah. Then after that, that first part of heating, we shall go directly to the part of dissolution. Aluminium sulfate and iron 3 sulfate, they are soluble in water. So it's going to dissolve completely in water to form yellow solution or brown solution. You choose one of the two. Then the other side, you conclude, you say that you deduct by saying iron 3 probably present. But remember, you have to separate iron 3 from aluminium. The only way, after getting that certain solution which is brown or yellow in color, we shall add sodium hydroxide dropwise until in excess to precipitate out iron 3 ions from the solution. So it means that we shall be with iron 3 ions in the residue, then aluminium ions, sulfate ions will be collected in the filtrate. That's the science behind addition of sodium hydroxide until excess to precipitate out the other iron 3 ion, which is insoluble in sodium hydroxide. Then we shall proceed by dividing. But before dividing, you also, in observation, you say that brown precipitate, you conclude by saying anything. Then colorless filtrate, you conclude by saying there is zinc, aluminium, lead, sulfate ion, chloride ion. Those ions which are colorless or which are white. Then you are going to divide the resultant solution or the filtrate into some good portions. The first portion, you are going to add sodium hydroxide. Since in the filtrate you have aluminium, sulfate, iron, chloride ion, we shall be able to see a white precipitate soluble. Remember, all ZAP members, that is zinc, aluminium, lead, are soluble. So we form white precipitate is soluble to form Kai solution. So the other side you say zinc, aluminium, lead. Then next table you add ammonium hydroxide. After addition of ammonium hydroxide, since in our filtrate you have that aluminium ion, we shall see a white precipitate insoluble. It means that you have eliminated zinc, because for the case of zinc is soluble in sodium hydroxide. So we shall continue with the lead and aluminium. We shall ignore zinc because for it is soluble. Then after, next table, we shall add potassium iodide to see whether lead 2 is there. After addition of the potassium iodide, no observable change. You will not see yellow precipitate anyway, since the lead 2 ions are not there. So you conclude by saying aluminium is confirmed. Now in filtrate we have remained with one anion, that is sulfate. Next part of table, we shall add lead 2, and you shall be able to observe that there is a white precipitate. That white precipitate represents that there is either sulfate or chloride ion. So that one is not a conformal test for any of the 2 ions, sulfate and chloride. So below that one, we shall add a reagent called barium nitrate followed by dilute nitric acid. So that reagent, for it is known that is able to confirm sulfate ion. So from that observation, we shall see that white precipitate, PPT or precipitate, will be formed, and we shall be able to confirm that sulfate ion is present. Now we are done with the filtrate. Now we are going to wash the residue, the other brown residue, using water or nitric acid. So there are only 3 tests or 2 their side, because we have only one anion, no cation, which is iron 3. That iron 3 gives the same observations on sodium hydroxide and the ammonium hydroxide. So we shall see brown precipitate throughout on either sodium hydroxide or ammonium hydroxide, and we shall conclude that iron 3 is present. Then we shall confirm iron 3 on ammonium hydroxide. So cation is present. After the table you see that aluminium and iron 3. Then anion, you say sulfate ion confirmed present. Since we have confirmed those ions in the table, thank you for listening. Assalamu alaikum wa rahmatullahi wa barakatuh. To all my fellow brothers and sisters who are following us on this page, Team Dr. Meddie. Big up to all my members. Thank you for listening. Goodbye.